Okay. Hi everyone. I am Srilantha. You can call me Sri. Um. So first of all, thank you for joining for this webinar. We really hope you would learn a lot. So last week you had learned and you are continuing to learn. I just am introducing what is machine learning, and the other speakers will continue showing the demo on using it on Kaggle and websites. So please stay tuned till the end of the webinar. Okay, so now the important question we all have in mind is what is ML and what is AI? AI is a bigger circle and ML is one part of it. So AI is anything which mimics the human activities. ML does a specific work well. So ML is basically part or a field of artificial intelligence, and it basically focuses on a particular problem solving. So that's how we say it on. It focuses on development of algorithms and models that enables the computers to learn and perform tasks without explicit programming. That's what we say. Machine learning. It does one task very well. It's a part of AI. Next slide, please. And if we see what are the different types of machine learning, as you might have heard, the major categories are supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is, as the name suggests, it's supervised. We tell the model, but we label the existing data and teach the machine this is a cat and this is how a cat looks and this is how a dog looks. And when new data has come, it compares with the existing data and tries to find the similarity, and then it figures out by itself whether the new image is a cat or a dog. So that is how the supervised learning works. We basically train the machine, we supervise the machine, we supervise the model. And the next one is unsupervised learning. And as the name suggests here, we don't actually tell the machine, we don't give the machines the labeled data. It figures out by itself. For examples of these are clustering. So it figures out the segments of the market by itself by looking at the similarities on the given data. And the next one is reinforcement learning. In this reinforcement learning, just like unsupervised learning, we don't give labeled data to the machine. Rather, the model starts to figure out, and we tell it whether it's learning or correct or not. We reinforce the model by telling, yes, this is correct, and no, that is wrong, by giving like either positive points or negative points. In simple words, we can say. So now what are the examples of one of these? The examples of supervised learning can be like the house price prediction or any classification techniques. Unsupervised are movie recommendations and any clustering kind of data. And reinforcement learning is the popular self-driving cars, which we give the positive or negative points from the way it learns about the road and etc. Next slide, please. Okay, you might be wondering, well, there are different types of machine learning, but how do they work? And why do we need machine learning, or how is it different from the traditional programming? Well, yes, we do have traditional programming in which, if we take this simplest, very common example, in the case of traditional programming, we get vegetables, we get chicken, and then, for example, take example of cooking in a oven or anything. The step one is cut the vegetables. Step two is season the chicken. Step three, preheat the oven. Step four is cook the chicken for 30 minutes, later add vegetables, and then hopefully we get a tasty dish as output. So in traditional programming, we start with inputs. We can say these steps as the program. So we give the inputs, we execute this program on the input and we get the output. So it's the straightforward. We do input, we do program, and we get the output. Whereas in machine learning, we have inputs and we have outputs, either by supervised or unsupervised way of learning, or reinforcement, as we have seen before, different types of machine learnings. But using either of those ways, this machine figures out itself through number of iterations, and then it comes out with a equally good or better dish by itself. So that's where the machine learning is shining these days. Next slide, please. So how do we use machine learning in the real world? As I was telling, some of the applications over there. So nowadays, machine learning is in every industry. I can think of an industry where there is the machine learning or AI is not used. Especially top of the list would be healthcare, where so many new so much of new research is going on, where they use it for whether the patient has cancer or not, whether they have any other disease or not, that which is the disease diagnosis, and what drugs to give. In finance, credit scoring, fraud detection. Fraud detection can be the supervised learning machine learning model. And then retail recommendation systems, as we were saying, and demand forecasting. We check how much of demand would be there for our product so that we can increase the sales. Autonomous vehicles, which we have seen every day, and NLP, chatbots, ChatGPT, all these are in NLP. Image and speech is really has gone a lot of advancements recently. And manufacturing industry is using a lot of machine learning with the help of predictive maintenance, cost reduction, and all that. Education is a greater sector where AI is being used, helping the candidates and students with personalized learning. And cyber security with the anomaly detection, fraud prevention. Fraud detection, as we were saying in the finance, cyber security is fraud prevention. So agriculture is the satellite data, crop monitoring, and the health of seagrass meadows or farm. All these are and many more actually are all different applications in the real world. So next slide, please. This is the simplest machine learning algorithm, simplest and the most powerful, we can say. So how does this is called a linear regression, and how does linear regression work? So this use case I have taken is, for example, given the house area in square feet. I know these numbers do not correlate with the real life, but consider it as a toy example. So on the x-axis is the house area in square feet, and on the y-axis is the house price. These are all the existing data points we have. So somebody told us that a house with 50 square feet has costed them the $50. And especially so like that for $170 had costed 170, and 140, whereas 140 square feet house had costed them $160. If you see different points with x and y axis. So the system tries to figure out and come up with a line joining all the points, the optimum line it draws. And whenever a new house has come with a new square feet, it tries to see, for example, the house with 70 square feet might cost around $80 if you see from the line. So it draws a line on the x-axis and finds it corresponding price on the y-axis. So this is math, the calculus, statistics. Linear regression has been there forever, and it's adapted in the machine learning. This is simple yet very powerful machine learning algorithm to understand. So I just wanted to give introduction of how the models work, and then other team members are continuing to show you how to run the models in the Kaggle and etc. Please ask if you have any questions.